Request all the students, all the viewers to respond. I request all the ones who are watching to respond. Problem statement. Let us solve some simple problems today. And then discuss the logic of some complex problems. So given a grid or a matrix of size m by n, find all possible paths for a person to reach the cell m by n from cell 1 1, or to reach m minus 1 n minus 1 from cell 0 0. So given a matrix of size 3 by 3, say m equal to 3, n equal to 3. So you are here, you need to reach this location. You are at cell 0 0 and you need to reach m minus 1 n minus 1. So tell me how many different ways are available, in how many different ways you can reach. If you are allowed to travel only towards right and towards bottom, you are allowed to take one step at a time to right and bottom or down. You cannot move left, you cannot move left, you cannot move up. You can move only right and down. Okay? So tell me how many different ways are available. So Pragna, Pranita, Ranjit, tell me how many different ways are available. In how many different ways one can reach destination from source? This is destination. I repeat, given a 3 by 3 matrix, or M by N matrix, a person here wants to reach destination. He can move right and he can move down. In how many different ways he can reach the destination? All possible ways. If you understood my question, please answer. Guess. At least make a guess. In how many different ways? So this is one way. This is other way, and this is one more way. Any other guesses? Any other guesses? Any other guesses? There are 6 ways. There are 6 ways on how to find out that. There are 6 different ways. This is one. This is two. This is three. This is four. And this is five. And this is six. Okay? Is this clear? Is this clear? One, two, three, four, five, and six. Okay? Is this clear? Come on, please respond. Okay, and how to do it? And how to solve it? Hmm? How to solve it? When you are here, okay, so you either move here or move here, right? That is, when you are at ij, you can go to I plus 1j, or or this is I plus 1j, or sorry, and this is I plus 1j, and this is ij minus 1. Okay, either you can go to I plus 1j or you can go to ij minus 1. Okay, is this clear? So from here, suppose you are at 0 0, you are at 0 0, you can go to, you can go to, you can go right, you can go right. What is that? 0 1, or you can go down. What is that? 1 0. Now from here again you can go here or you can go here. From 0 1, from 0 1, suppose you are at 1, you are here, you can go here or you can go here. From 0 1 you can go to 0 2, or you can go to, you can go to 1 1. Okay, from 1 0, from 1 0 you can go to, you can go to 1 1, or down, down is 2 0. Okay, is this clear? From 0 to, you can go only down. From 0 to, you can go only down. What is that? What is that? 1 2. From 1 1, from 1 1 you can go to, you can go to 1 2, or you can go to, you can go to 2 1. Okay, is this clear? Hope you understand it. Again from 1 2, you can go to, you can go to 2 2. From 2 1 you can go to 2 2. From 1 2 you can go to 2 2. Okay, from 2 0 you go to 2 1. From 2 1 you go to 2 2. From 1 1, from 1 1 you can go to 1 2 or 2 1. From 1 2 you can go to 2 2. From 2 1 you can go to 2 2. Okay, so there are 6 possible ways. Is this clear? So what you do is, you explore this path till you reach the end. Once you reach the end, once you reach the end, you get 1. Okay, here also 1. These two get added up here. This will become 2. Now this will become 2. This will become 2. This will become 4. And finally you get Finally you get 6. Okay, but the problem is, if you do it recursively, you solve the same problem many times. You solve 2 1 here, you solve 2 1 here, you solve 2 1 here. Okay, and you solve 1 2 here, you solve 1 2 here. So there are two approaches: backtracking, where same problem is solved many times, and second approach is memoization, storing subproblems. Let us see both of them. Let us do recursion first. Let us read number of rows and number of columns. Let us read number of rows and number of columns. Say space separated values. And map them into integers. And make it a list. Okay. Next. Say all unique paths are to be found out. To them pass m and n. Okay. And print the output. Print the output. Fine. Now, it is write function. Define a unique paths. Inputs are number of rows and number of columns. Okay. So assume that we are traveling from destination to source. We are traveling from destination to source. So source is 1 1. Okay. So suppose you are at 1 1. How many paths are available to reach 1 1 to 1 1? How many paths are available to reach from 1 1 to 1 1? If m equal to 1 and n equal to 1, how many paths are there? One path. Okay. From 1 1 to 1 1, how many paths are there? How many paths are there from 1 1 to 1 1? One path. Okay. Suppose you are here. Then what is it? I comma j plus 1. And if you are here, this is I plus 1 j. Okay. You may go here. You may come here, you may come here. Right? When you start from here, if you travel back If you travel back, this is I minus 1 j, and this is I j minus 1 if you are traveling back. Okay, so I cannot be less than 1, j cannot be less than 1. They are boundary conditions. They are boundary conditions. Now let us see. If m equal to 1 and n equal to 1, return 1. Now boundary condition. If m is less than 1 or n is less than 1, there is no path. There is no path. Okay. Otherwise, how many different paths are there? Hmm? You can go to, you can go right. When you go right, what happens? This is going right. Okay. And this is going left. Going right, sorry, and going up. Okay. Is this clear? In the same row, going left, going left. In the same row, going up. Okay. From top down approach, in top down approach, you have right movement and down movement. Okay. In down top approach, you have left movement and top movement. Okay. Now this is left movement and this is top movement. Okay. Is this clear? Is this clear? Okay. So let us find out number of ways. Left and this is up. If m equal to 1, n equal to return 1. If m is less than 1 or n is less than 1, return 0. So return unique number of paths. So where went wrong? Maybe mn values. I think input is not given. We did not give the input. It's asking for the input. Okay. Is this clear? How many paths are there? 6 paths are there. This is from top to bottom. Sorry, bottom to top. How to do it from top to bottom? How to do it from top to bottom? How to do it from top to bottom? Okay. You may be starting from 1 comma 1. You may be starting from 1 comma 1. Okay. Okay. Then if I equal to m, j equal to n, return 1. Okay. Now if I is greater than m or j is greater than n, then you are out of the grid. Okay. Otherwise you go right, you go down in the same column. Okay. And this is going down. Now go right in the same row. Okay. Now this is m and this is n. Fine. This is top to bottom. Let us check it works or not. So 3 rows and 3 columns. Okay. Is this clear? Is this clear? I have shown you both approaches from 1 to mn and mn to 1 bottom up and top bottom. Okay. Did you understand it? Is this clear? What is bottom up approach? What is bottom up approach? You start from mn. Okay. Now here, when you reach top, you return 1. Here, I must be, if I is less than 1, so out of bounds. If j is less than 1, this is out of bounds. Okay. Okay. And then from m, you go up, or you go right, or you go left. Okay. So this is bottom top approach. Bottom top approach. Somewhere I is there. This is m and this is also n. Okay. Again, somewhere trace of I is there. This is M and this is N. M is less than 1 and N is also less than 1. Okay, suppose you have 3 rows and 4 columns. Suppose you have 3 rows and 4 columns, you have 10 different ways. Suppose you start from 1 comma 1 and finally you reach Mn. I repeat, if I equal to M and J equal to N, okay, you reach destination. I should not be more than M. J should not be more than N. Okay, now this is going down and this is going right. Okay, fine. Now check. Oh. This is Mn only. This is M and this is N. Okay, so I hope you understood both the approaches, top down and bottom up. Next, memoization. Memoization. To see this, let us take a simple case. Assume that we start from here. From 0, 0, from 0 to 0, there's only one way. There's only one way to reach. From 0, 0 to 0, 0, there's only one way. From 0, 1, from 0, 1, in how many ways? From 0, 0, in how many ways you can reach it? In how many ways you can reach it? Only one way. Okay. From here, 0 to 0, from here only one way. From here also there is only one way. Okay. No. From here there is only one way. From here there is only one way. Now, from here you can go like this or you can go like this. There are two ways. Okay. From here, three ways. From here, three ways. From here, 6 ways. Is this clear? Is this clear? So, how to code this? Again, the approach is how to reach 0, 0. Again, the approach is how to reach 0, 0. 0, 0 can be reached from 0, 0 in one way. 0 0 can be reached from 0 0 in one way. Okay, from 1 0, from here there's only one way. From here there's only one way. From here one way. From here one way. Okay, from here there are two ways. You can go like this or you can go like this. Okay, now from here two ways, from here two ways and one way, three ways, 3 6. Okay, is this clear? This is called dynamic programming matrix. Dynamic programming matrix. Okay, see how we can implement it. So input is m and n. Now this is not a recursive one. Let us create a matrix, generally in literature called a DP matrix, with m rows and n columns, and put everything as 0. So for j in range n, for I in range n. Okay, now for I in range 0 to m minus 1 rows, for j in range, this is for columns. Okay, put 1 in the first row and first column. If I equal to 0 or j equal to 0, okay, then the matrix contains 1. Okay, otherwise the matrix contains so this is I and this is j. The score here is 1. The score here is 1. What is the score? So dp ij is equal to dp ij minus 1 plus dp I minus 1j. Okay, left cell and cell on the top. So what is this? Say left cell. What is left cell? I j minus 1. What is cell on the top? What is cell on the top? I minus 1 j. Okay, now return what? dp value in m minus 1 n minus 1. This is called memoization. So 2 required, 4 are given. Okay, now if you don't want m minus 1 n minus 1, if you want mn, then you start from 1. You start from 1. This is row 1, this is column 1. Make it m plus 1, make it n plus 1. So close to real life values. Okay. Okay. Is this clear? So we are leaving 0, 0, 0th row and 0th column. Now we move from 1 to m and 1 to n. Is this clear? This is close to real world. This is very close to real world. Say 3 rows and 4 columns. Hope you understand it. Is this clear? So in one simple problem, we discussed top-down approach, of recursion, bottom-up approach, of recursion, and memoization. This is recursion. Okay, and this is memoization. So I hope you understand it. So please let me know that you understood this or not. Okay. Say one more problem. Simple one though. Look here. Given a sequence of distinct numbers, given a sequence of distinct numbers, find out number of significant bits of each of them. For example, say 15, say 13, 7, 5, 2 are given. First, what you need to do is you should convert them into binary. This is 1, 0. What about this? Say 1, 0, 1. This is triple 1. This is 4 ones. And what about 13? Say this is 14. Okay. So this is 1, 1, 0, 1, 1, 0, 1. So 13 is 1, 1, 0, 1. 14, 15 is 4 ones. 15 is 4 ones, 7 is 3 ones, 5 is 3 ones, this is 2 ones. Okay, 3 1 0 1 1 0 1 and 1 0. Okay, so 3 4 3 2 1, these are number of significant bits in each number. Okay, if ai is greater than aj, then we call this as inversion. We call this as inversion. Find out how many inversions are there. Is 3 greater than 4? No. Is 4 greater than 3? Yes. Is 4 greater than 2? Yes. Is 4 greater than 1? Yes. Is 3 greater than 2? Yes. Is 3 greater than 1? Yes. Is 3 greater than 3? No. Is 3 greater than 2? Yes. Is 3 greater than 1? Yes. 3, 4, 3, next 2. So how many inversions are there? 1, 2, 3, 4, 5, 6, 7, 8. The answer is 8. Did you understand the problem? Did you understand the problem? First, convert the given set of numbers into binary numbers. Then find out count of significant digits. Okay. Then find out inversions. Inversion is the one where ai is greater than aj. 3 is not greater than 4. 3 is not greater than 3. But 3 is greater than 2. 3 is greater than 1. Okay. Similarly, 4 3 4 2 4 1 and then 3 2 3 1 and 2 1. There are 8 inversions here, and you need to report the number of inversions. Pragna, Pranita, Shravani, Anuhya, Ranjit, is this clear? Is this clear? Did you understand what to do? Did you understand what to do? So please respond. Okay, let us solve it. And with minimum number of statements possible. Now read number of numbers. First input. How many numbers are there? How many numbers are there? There are 5 numbers. Okay. Next, those numbers. Separated by blank space. How many numbers? N numbers. You should map them into integer and then make it a list. Okay, get them into binary numbers. So binary nums, right? So called a function by name to binary. Pass nums to it. Okay. Let us do one thing. Initially assume that binary nums are zero for I in range n. Okay. Now for I in range n, pass binary function ith number and store this in binary nums. Okay. Now let us write that simple function straight away. No need to discuss much about it. Binary numbers, input is say n. Okay, let that binary number having zeros and ones as a list, while n is greater than 0, start with I equal to 2. If n mod I equal to 0, so initially it is containing all zeros, empty one. If n mod I equal to 0, insert n mod I equal to 1. Insert 7 and mod 2 1. Insert 1 at 0 position. Else insert 0 at 0 position. Okay. Next, n is equal to n by 2. First 7 by 2, 3, 3 by 2, 1, 1 by 2, 0. Now return b. Print binary numbers. What are the numbers? There are 5 numbers. Fifty-five, 53, 88, 27, 33. 53 followed by 88, 27, 33. 88, 27 and 33. So no comma, only blank space. Let us do one thing. Let us put comma here, which is easier. Two binary is not defined. This is two binary. Five. So these are binary numbers. Okay. Now have one more list called as counts. Now counts I is also having zero counts in the beginning for I in range n. Counts I is equal to binary numbers I dot count of 1. Okay. Now print counts also. There are five numbers. So counts are 5, 4, 3, 4, 2. Okay. Next. So you have counts, you have binary numbers. Next step is getting inversions. For I in range n, for I in range n, for j in range n, if ai is greater than aj, then have a list by name inversions and add this to inversions. What do you add? You add a list contains counts I, comma counts j. Okay. Now print inversions or have count of inversions. Okay. So five numbers and these are the numbers. This is range. A is not defined. What is A? This is counts I and this is counts j. बाप रे. Okay, so 5 4, 5 3, 5 4, 5 2. How many are there? 1 2 3 4 5 6 7 8 9. I think 8 are required. How come we got 9? What is the answer? Answer is 8. But how many we got? We got 9. So this is I plus 1 to n. And this is n minus 1. 5. So 1, 2, 3, 4, 5, 6, 7, and 8. Is this clear? Is this clear? Next. You try this at home tomorrow, today, and we discuss it later. You can get them from Google. This is a problem of triangles. Largest number problem. Heights of students. So finding product. Arcade problem. Lattice discs. So these were all problems asked earlier. You can get them from Google. Okay. Okay then. Hope you understand the session.